Hello, welcome. This is going to be Final Exam Review Part C2, and basically we're going to start talking about rationals. First set of problems is going to be something that asks you for the domain. So it's very important that you just focus your attention on the denominator, the numbers on the bottom. We do not care about the numbers on top. Okay. Basically, what you're going to do on the numbers on the bottom, you're going to factor. So I multiply 1 times 10, get 10, create a list of numbers that give me 10, and then I'm looking for something that gives me the middle term, which is 3, and basically this would be positive 2, negative 5. So basically these are my numbers, and I want to make sure that my denominator will never equal 0. So basically x plus 2 times x minus 5 must be different than 0. So that means x must be different than negative 2 and x must be different than 5. So this would be my answer right there. Okay. The next problem is I have 2x minus 1. Remember, domain is just focus on the denominator, so 2x minus 1 must be different than 0. Solve for x. We get that the domain must be x different than 1/2. The next problem, you are asked to simplify the rational or simplify the fraction, and first thing that you're supposed to do is always try to factor. So always try to factor. So if I try to factor the top, I can factor out a 2. On the bottom, there's nothing I can do, so I just leave it as it is. And as you can see, you can cancel top and bottom, and you're left with a 2. I can tell you for sure that there will be a question just like number 1, number 2, and number 3 on the final exam. So it's very important that you look at these 3 problems, since they will be similar problems on the final exam. All 3 questions will be multiple choice. Okay. Alright. Let's go on to the next problems. The next problems continues to be simplifying the rational. Basically the strategy is the same. Factor the top, factor the bottom. Once you factor, look for things that you can cancel. And I cancel and I got this answer. Okay. Here, again, factor the top, factor the bottom. In this case, I was not able to factor the top, but I'm able to factor the bottom. Okay, I'm not going to go through every step of factoring. Basically, I'm just going to say that we can factor. And if you remember, this is how you factor. Once you factor, look for something that can be canceled. And remember, if you cancel the numbers on top, you put a 1. Okay. Alright, let's go on to the next problem. Here, factor the top, factor the bottom, factor the top, factor the bottom. I'll look very carefully at this one here. This is one of those special factors. If you see x squared, excuse me, perfect squares with a minus in the middle, remember you can write x plus 2, x minus 2. There will be a question like that on the test. Okay, so please remember that this is a special factor. Okay, so basically I factor the top and bottom, and then I look for some things that I can cancel. Everything on top I cancel except for the 2, and on the bottom the only thing that didn't cancel is x plus 2. So excuse me, look at these examples. Remember, the strategy is factor first and then cancel. Okay, so there will be questions with multiplication as well as division. With the division, again, as always, try to factor top, bottom, then copy the first fraction, change the division sign to times, flip the second term. Then the last thing you do is cancel. We cancel everything, and everything that is left is the answer. So here's another example. Okay. In fact, here I drew this cross over here, and I did the factoring of the top, factoring of the bottom, top and bottom. I rewrote my fractions. I copied the first in factor form. I changed division to times. I flipped it, and then the last thing I do is cancel. Okay. Here again, same thing. Factor first, copy the first fraction, change to times, flip the second term. Okay. I will not give problems like this with 3 fractions, nor I'm going to give numbers like this, 5 minus 20x squared, where you have to flip them around. Okay, so in fact, if you don't want to worry about number 16, that's fine. Just make sure you do the review, but I wouldn't stress about these kind of problems. Not going to be that big on the final. Okay, again, all these problems will be multiple choice. So please remember, factor first, cancel second. Okay? Alright, then we move on to the next set of problems, which is adding and subtracting rationals. Okay? And I told you in class that I'm going to have 2 questions like this. Okay? Where the denominator is going to be the same. So all you have to do is add the top. Please be careful not to add the bottom. The bottom is a common denominator, so it stays the same. Very often students will add x plus x is 2x, 4 plus 4 equals 8, and that is wrong. Notice that x plus 4, common denominator is still x plus 4. All I do is combine the top. And I get 7x minus 7. Okay, this one, again, you have a common denominator. The one thing you have to worry about is the fact that there is a negative. So you must distribute that negative. Okay? So if you notice, I rewrote it with a common denominator. I put a negative and I put parentheses to remind you that you need to distribute. Negative times a positive is a negative. Negative times a negative is a positive. You combine them and you get this problem right there. Okay? So again, look for these problems. They should be easy. Just be careful with your signs. Now, these problems have the same denominator. The next problem does not have the same denominator. And yes, there will be problems like this on the final too. First thing you need to do is factor the denominators. If you notice, I factor the first denominator by factoring out the 4. And then I'm going to compare the 2 denominators. See, I wrote the first denominator, which is this guy right there, and the second denominator, making sure to line up anything that is the same. And then I write them for my LCD. So I have a 4 and I have x plus 1. So my least common denominator is 4x plus 1. Once I have this in mind, I copy my first fraction, making sure the denominator is in its factor form. And then I look at my denominator and compare with my LCD. Is there anything missing? In this case, there's nothing missing. So I go on to the next fraction. I bring it down and I ask myself, is there anything missing for the denominator when I compare with the LCD? In this case, yes, there is. I'm missing a 4. So that tells me I'm going to multiply top and bottom by the 4. Now that I have a common denominator, I can write just one denominator. I copy the number of the first, but on the second, I distribute the 4. 4 times 3x is 12x. 4 times negative 1 is negative 4. Combine like terms, I get 16x minus 9 over 4x plus 1. Alright, problem number 4. Similar problem where I don't have a common denominator. So first thing, try to factor. I factored this trinomial and I got x minus 2, x minus 5. Line up my denominators. Here's my first denominator. Here's my second denominator. Okay. Decide on your least common denominator. Okay. And once I have my least common denominator, copy the first fraction and ask yourself, what am I missing when I compare with my LCD? I'm missing an x minus 2. So that tells me I multiply top and bottom by x minus 2. Copy the second fraction in its factor form. Compare with the LCD. Nothing is missing, so leave it alone. Now let's write under one same denominator and distribute that 4. 4 times x is 4x. 4 times 2 is negative 8. Combine like terms, x minus 8. And that's my final answer right there. Okay. Alright. Following is a few more problems where you have to find the common denominator. Okay. And Here's another example too. Okay, so please look at this as you prepare yourself for these types of questions where you have to find the common denominator. Okay. The next set of problems will be radical equations. Radical equations have the radicals, and basically what you have to do to get rid of the radical is multiply both sides by that number that's right here. In other words, the root. So if this is fourth root, you're going to raise both sides to the fourth power. If this was cube root, you raise to the third power. If there's no number there, that means square, so you square both sides. Once you square, in this case, once you raise to fourth power, the exponent cancels the radical. You're left to 10x plus 11, and then you get 81, and then all you do is solve for x. Always remember to check your answers. How do I check? Go to the original problem, copy the problem, but instead of x, put the number that you found for your answer. And basically what you're doing, you're trying to solve both sides and making sure both sides is the same. If it's the same, that means that x that you found is valid. If this was 3 equals negative 3, then this would be wrong, and then this would be invalid. So that's just very important to check your answers. Okay. Here's another example of a radical equation. This time is square. So you square both sides. Notice here that I have x minus 5 squared. So basically you write x minus 5 twice. And then you apply FOIL. FOIL is first times first equals x squared. And then the outside numbers, the inside numbers, then combine it. And the last times last gives you 25. Move everything to one side to make sure that one side is 0. Combine like terms. Then you factor. 1 times 24 is 24. What numbers give me 24? Negative 3 and negative 8. So that means I can write x minus 3, x minus 8. In other words, x must be equals 3, x equals 8. Very important. Make sure you check your answers. And if in this case, when we checked, we noticed that 3 is not a valid answer. And we also noticed that 8, it is a valid answer. Remember, this is going to be multiple choice questions, so most likely if this was a question on the test, maybe the multiple choice would say A, the answer is 3, B, the answer is 8, C, the answer is 3 and 8, and D, maybe the answer is no solution. Okay, so you have to decide, so you need to make sure to check your answers. Okay, there will be a question like this. A lot of people get scared because they look at this and they're like, oh my goodness, what do I do this? When you see something like this, just change it to radicals. Basically, 1 over 2 means this is going to be the square root. So basically, I'm copying everything the same except for that 1/2, I'm changing to a square root. Once you have the square root, you square both sides. The square root goes away. Here I get x squared. Make sure one side gets to be 0. Factor it, then you have two answers. Make sure you check, and in this case we found out that negative 5 is not valid. Okay, this is also a radical equation. There will not be such a problem like this on the final, but basically you square both sides. In this case, when you square it, the 2 you need to distribute, so this would be 3 squared, and then the square cancels the radical. Then you solve for x, check your x, see if that 9 works, and in this case it does work, so your answer is x equals 9. Okay, but if nothing else, questions number 7, 8, and 9 will be very important for you to study because there will be similar questions on the final exam. They're all going to be multiple choice. Okay. Alright, let's go to radicals. Okay. You're going to have 3 questions on radicals like this where you'll be asked to simplify. I promise to you there's not going to be big numbers like this, but it might be something smaller like 32 or 80, 81 or something like that. And basically what you do is you do the prime factorization. Once you do the prime factorization, write the numbers, right, with their exponents. And remember, square root means that there's an invisible 2 right there. So basically you want to make sure the exponents can be divided by 2. In this case, this guy can, The x19 cannot, so what you need to do is rewrite. So we write as x18, x to the first. And basically, remember, we put the little arrow to signify that this guy can come out, this guy can come out, this guy cannot come out because you cannot divide 1 by the invisible 2. This guy can come out because 18 can be divided by the invisible 2. This one cannot come out, this one can come out. So now, go ahead and remove them. When they come out, you divide the exponent. So 2 divided by the invisible 2 is 1. 18 divided by the invisible 2 is 9. And 14 divided by the invisible 2 is 7. And whatever doesn't have an arrow coming out, that means that's what's staying in the radical. Once you have the numbers outside, make sure you combine them. So 2 times 3 is 6. And that's your answer. So here I have other examples. Okay, some examples have numbers on the outside. Please don't forget to write them. You know, a lot of times students do the prime factorization, write them in here, but they forget to copy the number that is outside. Okay, basically for a few steps you're going to copy that number. But once the numbers start coming out of the radical, then you need to multiply these numbers that came out with the number that was already outside. So in this case, negative 3 times 2 times 3 to the second gives you negative 54. And x to the first times x to the fifth, x to the sixth. Okay? So there will be about 3 questions similar to these. Again, not with such big numbers like 29,106, but with something more smaller like 243 or things like that. Okay? There will be one question where trying to look where you're going to have something with a negative inside. Remember, the negative comes out as an I. So the negative comes out of the radical as an I. So and also one of the questions, remember there's 3, will be either 4th root or cube root. So for example, if it's 4th root, we're dividing by 4. Okay, so when you rewrite it, like for example x to the 9th, when you rewrite it, you want to write it as a multiple of 4. So how do you break down 9? 8 times 8 and 1. On this problem right here, we want something that can be divided by 3. So for example, 2 to the 8th, can it be divided by 3? No. So I need to rewrite it as 2 to the 6th, 2 to the second. Why 2 to the 6th? Because 6 can be divided by 3. Same thing occurred here with 29. We rewrote it as y to the 27th and y to the second. So you can divide 27 by the 3. Okay? I'm not going to go through every problem step by step, but basically I'm giving you a general idea of things to watch out for. Okay? So there will be 3 questions similar to this. Make sure you understand these problems. Okay? And that concludes part C2 of your final exam review. Thank you very much for your time and have a great day.